Hi there, it's Diane. Welcome to my basement. Today we're going to be learning about equivalent fractions. I'm on page 27 in your workbook. The first question you should ask yourself is, what is an equivalent fraction? Well, equivalent fractions are fractions that represent the same value with respect to a whole. The whole can be a single integer or a collection. So let's look at this. Equivalent fractions in an integer. So here they show us 1/2, 2/4, and 4/8. What do you notice? I notice that 1/2 has the same value that's shaded in as 2/4 and as 4/8. That means that the fractions 1/2, 2/4, and 4/8 are equivalent. They equal the same value since they all represent the same surface, which is 1/2 of the whole. Interesting. Let's look at a collection. Equivalent fractions in a collection. Here, you see that there are 4 red marbles. 1, 2, 3, 4. And the total bag has 16 marbles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if we were to put our marbles into 4 groups, 4 equal groups, we would see that one of the 4 groups is red. If we were then to divide the groups into 8 equal groups and we put 2 marbles into each group, we would see that 2 of the 8 total groups are red. We could also see that if we put 1 marble in each group, you would have 16 groups, and 4 of those groups would be red. So we say that 1/4, 2/8, and 4/16 are equivalent. They equal the same value since they all represent the same number of marbles, 4 out of 16. Let's try some practice with this. You can go ahead and turn your book to page 28. Okay, so here we are working with circles, and it says write the missing numerators and denominators to make the 2 fractions equivalent. So the first one, they've written 8, and they want to know how many total slices or how many total parts was the circle divided into. I count it usually like a clock. So I start at the top and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 8 parts have been shaded in out of a total 12 parts. Great. Well, here we have the same value that's been shaded, but we have different parts that are the total. They've divided into not 12 equal parts. How many parts have they divided this circle into? 1, 2, 3, 4, 5, 6. So our total is going to be 6 equal parts. And how many parts have been shaded? 1, 2, 3, 4. 4 out of the 6 total parts have been shaded. Let's look at the last circle. They've divided the last circle into how many total parts? Are you counting? 1, 2, 3? Great. They've divided our circle into 3 total parts. And how many are shaded? 2. 2/3. So they're telling us that 8/12 equals the same value as 4/6, which equals the same value as 2/3. Let's move on. B. So here we have 4 parts that are shaded out of how many total parts? Now in the past, some students have written they see 2 that are not shaded. So they put a 2 in the denominator. But don't be fooled, don't be tricked. It's not the parts that are not shaded, it's the total parts. So you have to count all the pieces. 1, 2, 3, 4, 5, 6. So 4 out of 6 parts have been shaded. Keep that in mind when you do the next one. So, how many parts have been shaded? 1, 2, 3, 4, 5, 6. And how many total parts are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 6. Sorry, 6/9. Let's look at the last one. If 4/6 equals 6/9, and we divide our circle into even more parts, what does our fraction, what's the equivalent fraction? I'll give you a second. Your numerator are the parts that are shaded. Your denominator are the total number of equal parts. So it doesn't matter if you write the denominator first or the numerator first, as long as you have the right number in your denominator and the right number in your numerator. So if you want to go ahead and count the parts that are shaded first, you can do that. 1, 2, 3, 4, 5, 6, 7, 8. 8 out of a total 9, 10, 11, 12. So you should have 8/12. That's all you need to do. You count the total number that are shaded out of the total number that are divided. Numerator, number on top, denominator, number on the bottom. Let's move on. There's a little more I want to show you. So here we have 3/5. So 3 ducks have been circled out of a total 5 ducks. 3/5. Now they want to know what is the equivalent fraction if it was out of 10 ducks. I like to look at columns. So I see 1, 2, 3, 4, 5 columns. And 1, 2, 3 have been circled. So I circle 1, 2, 3 columns. And then you can just count the ducks that are inside. So 3/5 is the same as how many tenths? 1, 2, 3, 4, 5, 6. 6/10. 3/5 equals 6/10. Now, I know some of you are going to say, how in the world can 3/5 equal the same as 6/10? I'm going to prove it to you with my calculator. If I take 3 and I divide it by 5, it equals 6/10. 0.6 is 0 and 6/10. Remember, the 6 is in the 10th position. And then if we take 6 divided by 10, it also equals 6/10. Crazy, isn't it? Let's look at the next example. So they give you 9 sharks have been circled. 1, 2, 3, 4, 5, 6, 7, 8, 9 sharks have been circled. And they want to know what this represents out of the total number of sharks they've given you. So all you have to do for the denominator is count all the sharks that have been given. Now you already know this is 9, so I'm going to start at 9 and I'm going to add the other sharks. So 9, 10, 11, 12, 13, 14, 15. So I have 9/15 of the sharks have been circled. Now I look at the columns and I see that out of 1, 2, 3, 4, 5 columns, 1, 2, 3 columns have been circled. So I circle 3, 1, 2, 3 out of the 5 total columns, and then I count. 1, 2, 3 have been circled out of a total of 1, 2, 3, 4, 5. 3/5. Now, if you want to check to make sure that your answers are correct, we can use our calculator. 9 divided by 15 is 6/10. That number looks familiar. And then 3 divided by 5, guess what it's going to equal? 6/10. And we can see that because we had the same number earlier. Do you see how we had 3/5 with our ducks? So 3/5 equals 6/10, which also equals 9/15, which equals 3/5 again. That's pretty crazy. Okay, let's try one more. The next one's fun. It's with dogs. So here we see that it says there are 20 dogs walking in the park, including 4 bulldogs. So here are 4 bulldogs. 1, 2, 3, 4 bulldogs. It says complete the sentences. So they give us sentences A, B, and C. Let's complete them based on our bulldogs. Okay. The bulldogs represent how many of the 20 dogs walking in the park. So if our total is 20, how many are bulldogs? Well, you can always circle them. Out of 20, because if I divide this into 20 circles, right? 20 just means there's 1 dog in each circle. I would have 20 groups. And they want to know how many groups would have a bulldog in it. 1, 2, 3, 4. So the bulldogs represent 4/20ths of the dogs walking in the park. We can also say, I'm at B now, we can also say that the bulldogs represent blank fifths of the dogs. Blank fifths. So now they want us to put the dogs into groups of 5. 1, 2, 3, 4, 5. All right. There's a group of 5. 1, 2, 3, 4, 5. Okay, there's another group of 5. Another group of 5. And another group of 5. We can also say that the bulldogs represent blank out of 5. So if they're into groups of 5, how many bulldogs represent blank out of 5? You know what? I put it into 5. So it should be, nope, I did it wrong. Look at that. They want to know. This one's tricky, isn't it? How do you divide 20 into 5 equal groups? I just divided it into 4 equal groups and I put 5 dogs into each group. They don't want that. They want 5 equal groups. Ooh. So if you were to put it into 5 equal groups, you would have 1, 2, 3, 4, 5 equal groups. We can also say that the bulldogs represent, how many are there? 1. One group is the bulldogs, isn't it? So 1 out of 5. Wow. 1 out of the 5 total groups. Do you see my groups? 1, 2, 3, 4, 5 total groups. That's what they asked for. 1 whole group is going to be our bulldog. Don't make the same mistake I made. I put it into groups of 4 originally, and I put 5 dogs into each group, but that's not what they're asking. Sometimes you make mistakes. That's okay. Let's look at the next question. So we can also say that the bulldogs represent 1 out of 5 groups, or 2 out of how many? Ooh. So look, now I'm going to put them into 2 groups. So I'm going to have to put 2 dogs into every group. Do you see that? So if 2 of my groups have bulldogs in them, how many total groups do I have? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 out of the 10 have bulldogs in them. There we go. We figured it out. 2 out of 10. Way to go. Are we ready for the C, the last one? Yeah, you are. The fractions. So what fractions did we create? We created 4 20ths. So 4 dogs out of 20 total groups, or 4 groups out of 20 total groups, were bulldogs. But then we broke it down into groups of 5. We wanted 5 groups. It's the amount of groups, not the amount of dogs in each group. That one's tricky. So 5 groups. I divided 1, 2, 3, 4, 5. 1 whole group was a bulldog group. And then they said, wait a second, divide them into groups of 2. 2 of your groups are going to have bulldogs, so I did 1, 2. So 2 out of a total 10 groups had bulldogs. We saw that. So you have to remember the numerator is the amount you have circled or shaded out of the total amount of groups. All right, so keep that in mind. Now they're telling us that 4 20ths equals 1/5, which equals 2 tenths. It's an easy way to check that. We use our handy dandy calculator and we take 4 divided by 20. That equals 2 tenths. Then we take 1 divided by 5. That equals 2 tenths. Then we take 2 divided by 10, and that equals 2/10. So they all equal the same value. Now, some of you are wondering, how in the world does 4/20 equal 1/5, which also equals 2/10? None of that makes sense to me. Let me explain why that works, okay? You don't really need this, but I think it's important you understand why it works, okay? So, do you remember when I told you that 2 shaded out of 2 equals 1 whole? Because watch, if you have a shape that's divided into 2 equal parts, and you shade in both parts, then the whole object has been shaded in. What if I had 5/5? So I take a rectangle, I divide it into 5 equal parts, and I shade in 5 parts. 1, 2, 3, 4, 5. 5/5 equals 1 whole because it's all shaded in. So 100 1/100ths equals 1. 30 30ths equals 1. What am I trying to get at? You now understand all of this. I know. So let's go back to 4/20, 1/5, and 2/10. The other thing you have to remember is any number times 1, it equals itself. So 3 times 1 equals 3. 5 times 1 equals 5. You can remember that as well. I know. Okay, let me teach you something you don't know. So watch this. If I have 20 and I divide it by 4, I get the number 5. But if I divide 4 by 4 as well, I get the number 1. So watch this. I'm dividing 4/20 by 4/4. And 4/4 equals 1. So any number I divide by 1, I get the same number. That's crazy! It works for division and multiplication. Watch this. 5 times 2 equals 10, but 1 times 2 equals 2. So all I've done is I've taken 1/5 and I've multiplied it by 2/2. And 2/2 is 1. So all I've done is I've taken a number, I've divided it by 1, I've taken a number, I've multiplied it by 1, and every time I get the number that has the same value. They all equal 0.2 or 2/10. That's crazy. Watch, we'll try another one. Okay, let's say I give you a picture of 3 kids. Let's look at these 3 kids. All right, so we've got these 3 kids here. Do you see them? Cute little kids. All right, so we're going to look at this picture. And we're going to find the fraction 2/3. How could we divide these kids into 2/3? I want 2 kids circled out of 3 kids. What do I mean by that? Okay, so 2/3 of the kids have on a green shirt. Would you agree? 2 of the 3 kids have on a green shirt. Do you see any other ways we can represent 2/3 with these kids, with these students here? Well, 2/3 have short hair. It's kind of hard to see the picture. 2/3 have on pants. 2/3 are not wearing a watch. There's many ways to divide this picture into 2/3. That's great. You can keep thinking of some, but let's find some equivalent fractions of 2/3. So, 2/3 is the same as how many 6? What if they had a twin and their twins wore the same outfit or looked exactly like these 3 students here, these 3 kids? What would the equivalent fraction be of 2/3? Do you remember how we do this? You can draw a picture. You can say 2 of the 3 are circled, and then if you were to draw 6, because I've done it twice, then you would have to circle 2 of the columns. So it would be how many? 1, 2, 3, 4 out of 6. That's one way to do it, and that's perfectly all right. Or you know that 3 times 2 is 6, and whatever number you multiply the bottom, the denominator by, you have to multiply the numerator by. So 2 times 2 equals 4, and we know that 2 over 2 is 1. So any number times 1 is going to equal itself. The value is going to stay the same, right? What about, they were triplets, oh my goodness, 9 kids. How many 9ths does that equal? You want to do the dots again? We can do the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now remember we circled 1, 2 columns, 1, 2 columns. So now I'm going to make sure that I circle the 2 columns. So it equals 1, 2, 3, 4, 5, 6 ninths. If you want to multiply, you can do 6 times, oh, can you? 6 times what number is 9? You can't do it that way. You can go back to 2/3. We can do that. I'm going to change my color. Let's go to red. So, 2 times what number is 6? 2 times 3 is 6. And 3 times 3 is 9. So 2/3 should equal 6 ninths. Very cool. What about we check our answer with our calculator? We can do that. We can do anything. Because we are amazing, aren't we? Okay, there's a little shadow. We're good. So if I take 2 divided by 3, it equals, oh, look at that number. It's rounded a bit. But basically, 66 hundredths. 66666666667. It's a lot. Let's look at 4, 6. 4 divided by 6. Same number. And then we look at 6 divided by 9. It's the same number. You can round it, it would be 67 hundredths. That is a very cool way to check your work, to make sure that your numbers, your fractions, are equivalent. They equal the same value. You can use numbers, you can use dots, just as long as the value is the same. All right, well, stay curious. I'll see you next time. Great job today. Bye.